In this video for Chapter 11, we're going to go over effect size. So you can follow along with your student-led example. So here are the formulas for effect size. They're similar to what we've seen before in previous chapters, but now instead of having the mean, we're having the mean difference. R squared, again, I'm not going to hold you responsible for in terms of an exam, but it will possibly be in the MindTap examples. And then this is our confidence interval formula. All stuff we've seen before, so it should look familiar. So here's our student-led example. First, we want to calculate Cohen's d. Cohen's d is going to give us a formula of our mean difference score over our standard deviation. So we're given variance here, so we know that the standard deviation equals the square root of our variance, which means that our standard deviation equals 10. We know our mean difference score, so our Cohen's d is just taking 12.7 over 10, which is going to give us a value of 1.27, which is a very large Cohen's d. Next, we're going to construct a confidence interval. So we want to construct a 90% confidence interval. So that means we're going to look up in our table for the critical t for the formula, and the formula for our confidence interval is going to be that our mean population difference will be between the mean sample distance plus or minus our t for our critical alpha times our estimated standard error of the mean difference. So first we need to get our estimated standard error of the mean difference. It's going to be the square root of our variance over our sample size, which we said before was our square root of 4, which is equal to 2. Next, we need to get this t value. So we're going to go to our table and look it up. We want to look up 90% confidence interval, which gives us 10% left over, which is going to give us an alpha of 0.1. And again, remember, we're doing a one-tailed test. So because we did a one-tailed hypothesis test, we want to stick with a one-tailed confidence. So here we are at our table. We have the proportions in one tail, 0.1. We go down to our degrees of freedom, which was 24. And the value that we want is 1.318. Now, if you were doing a two-tailed test, the value would be different, correct? Here for two-tailed, it'd be 1.711. So we calculated just a little bit ago that our estimated standard error was 2. We know the critical t that we want is 1.318. We said that our formula for our confidence interval, with the mean difference, would be equal sample mean difference plus or minus the critical t times estimated standard error. So this value is going to be sample mean difference, which is 12.7 plus or minus 1.318 times 2. Which is going to give us 12.7 plus or minus 2.636, which ends up giving us the values between 10.064 to 15.336. So this is our confidence interval. So again, we're 90% confident that if we were to repeat the study again, our sample mean difference would fall in between these values.